1. A material of dielectric constant K is placed as shown. First case, it is dividing the distance.
Sir,
Yes.
you're not audible.
Now it is okay. Hello, now I'm audible. Hello. Now I'm audible. Now.
Yes, sir.
Yes, sir.
First time distance divided, second time area divided. A by 2, A by 2. The ratio of capacitance in the two case we want. So first one, is it series combination? First one. Whenever distance divided, it is series combination we have written, correct? Because if this plate is positive, this plate is negative, then field will go from positive to negative, positive to negative. Plus minus is series combination. So first behaves like series, second behaves like parallel. And we have written in theory notes, when distance is divided, series combination, area divided, parallel combination. Are you remembering this?
Yes, sir.
Okay. What is C in series combination formula?
1 upon C.
That is okay. If same plates are divided into two by dielectric, then this was the formula. A epsilon 0 D1 upon K1, that means T1 upon K1 plus T2 upon K2 dot dot dot. Are you remembering this formula?
Yes, sir.
So this will further become A epsilon naught D by 2 into 1 upon 1 plus D by 2 into 1 upon K. So this is equals to A epsilon naught D by 2 into 1 plus 1 upon K. So it is equals to, this 2 will go up. 2 times A epsilon naught D A plus 1 upon K. So K will go up. I will get 2A epsilon naught K upon D into K plus 1. First formula for series combination when dielectric divides the distance. Just copy this much. This formula, please remember, when series combination divided by dielectric, then same area, same epsilon, but that D will become T1 upon K1 plus T2 upon K2 plus dot dot dot. First combination done, series wala.
Yes, sir.
If it is parallel, then epsilon naught what is formula, tell now if you are remembering what is formula. Epsilon naught upon d into a1 k1 plus a2 k2 dot dot dot. Here only 2, so we will stop at 2. So this will become epsilon naught by d, area a by 2, first dielectric is 1, so into 1 plus a by 2 into k. So it is equals to a by 2 epsilon naught by d into k plus 1 second. So ratio of first to second, that is first combination to second combination, will become C series upon C parallel is 2a epsilon naught a by d a plus 1 divided by 2b upon a epsilon naught k plus 1. A epsilon naught cancel. B cancel. So it becomes 4k upon k plus 1 the whole square. This is the required answer. 4k upon k plus 1 square. Completed, please convey. Vatsal,
Yes, sir.
started practicing MCQs?
No, sir.
No, you are waiting for some auspicious day to come.
No, sir.
When you are going to start? Yes.
Uh, Today.
So today we'll start practicing. Okay. Start as soon as possible. Why you are waiting? Neil? Hello, Neil? Hello, Neil?
Yes, sir.
Started practicing MCQs? Daily 2020?
Yes, sir.
Okay. Raut? Atharva Raut?
Yes, sir.
Started practicing 2020?
Yes.
Okay. Janvi?
Yes, sir.
Have you started practicing MCQs?
Yes, sir.
Okay. Vijay?
Yes, sir.
Have you started the 2020 MCQs daily and 2 theories?
Yes, sir.
Okay, Amy, what about you?
Yes, I have started.
20 MCQs daily you have started practicing with two theories.
Yes, sir.
Rohan, Ravi,
Yes, sir.
all of you have started.
Yes, sir.
Vedant,
Yes, sir.
Amonika,
Yes, sir.
Yes, sir.
Yes, sir.
that should reflect in your mark. And if you are doing honestly, if any doubt comes, please ask. Don't think that sir will ask. Your doubt you should ask. 99. In the given arrangement of parallel plate, there is some arrangement given. Distance between two plate is D, area A, equivalent capacitance between X and Y is C, which is K times C is K times A epsilon 0 by D. This K factor I have to find. These are plates. Y, 4 plates. 1, 2, 3, 4 plates. Second is connected to X. 1 and 4 are joined together. Between this plate, K is given 3, K is 5, K is 3, K is 6. Now, if I can rearrange this structure as series parallel combination, I can find equivalent. First plate is suppose positive, then fourth will also become positive because both are joined together. So 1 and 4 I am connecting together to Y lines. First plate, fourth. Then second one is connected to negative terminal. So this plus and minus becomes one plate. Second का दूसरा end, फोर्थ के सामने थर्ड है. थर्ड को किसी के साथ कनेक्ट नहीं किया, वो खुद के साथ कनेक्ट किया. ये थर्ड दोनों को ज्वाइन किया तो सिंगल प्लेट हो जाएगा, बट वी कैन एज्यूम इट टू बी सेपरेटेड. एंड सेकेंड का दोनों साइड इज नेगेटिव. सो दिस बिकम्स अवर 3 condensers. No? Is connection followed?
Yes,
Yes,
sir.
sir.
Now 1 and 2 के बीच में there is dielectric of 5, 2 and 3 के बीच में 3, 3 and 4 का बीच में 2 and 3 के बीच में 3, and 3 and 4 it is 6 dielectric. So C1 is A K epsilon naught by D. This I am calling C1. C2 A K epsilon 0 by D. C3 A K epsilon 0 by D. Now C2 and C3. C2 and C3 they are in series. So result of that I will get CS is C2 C3 upon C2 plus C3, that is product upon sum. So this equals to A into 6 epsilon 0 by D into A into 3 epsilon 0 by D upon, when you add 6 and 3 will become 9 A epsilon 0 by D. That means it is 6 3s are 18 A epsilon 0 by D into A epsilon 0 by D upon 9 times A epsilon 0 by D. A epsilon 0 by D cancel, 9 into 15, that is 2 times A epsilon 0 by D. Then then C parallel will become C1 plus CS. C1 is 5A epsilon 0 by D plus 2A epsilon 0 by D. That will be 7A epsilon 0 by D. That is, if I compare with this, K will become 7. Answer K is 7. Anybody who has not followed? Hello? Anybody who has not followed this sum? First plate, second plate, one condenser I have arranged like this. Second का दूसरा end is separated, but second is same. तो इसलिए इसको अकेले को y के साथ कनेक्ट किया. थर्ड का कनेक्शन किसके साथ भी नहीं, ऐसा किया. 1 and 4 joined together. Yes, everybody has followed.
Yes, sir.
Yeah, shall I clear this?
Yes, sir.
Come to sum number 100. Select the incorrect statement from the following. Two identical capacitors are charged individually. Two identical means same capacity. Same capacity. Are charged individually means different voltages. V1, V2. After disconnecting them from the source, if they are connected parallel to each other, they are connected parallel to each other. When connected parallel to each other, then net charge, if this is charge Q1, this is charge Q2, then net charge, this is Q1, this is Q2, will become Q1 plus Q2. They are telling incorrect, this is correct straight, but we want incorrect one. Net energy stored in the capacitor is less than sum of the initial individual. So U1 is half C1 V1 square. U2 is half C2 V2 square. U of system will be half of C1 plus C2 parallel into V square. Always Q1 plus Q2 is greater than sum. So net energy of two capacitor is less than this because individually sum is more as compared to when they are combined together. You can check after simplifying. So this, remember this statement. C. Net potential across them is different from the sum of net potential across them. It's V, suppose this is V, this is V. This is not equal to V1 plus V2. That means net potential across them is different from the sum is also correct. D. Net potential across them is equal to sum of potential is incorrect. This is marked. Right, all the statements first, second, third are correct. D is incorrect. That is our option. They want which is incorrect. Done.
Done, sir.
In the circuit shown, if C is 6, what is the energy stored in the capacitor? Diagram is not given, just draw this diagram. C, 2C. The charge stored in capacitor is how much? This is 10. C and 2C, then 10 volt, or this is also one. The same you can draw like this. One condenser, second condenser, both are earth together. So this is one battery, together it is earth, one and the same. When I join this, this is together. Now C, 2C, 10 volt. We want what is charge stored across. To get charge, first we require total capacity, because in this total charge will keep on flowing. So total capacity of two condenser is product upon sum, that is 2C square upon 3C, 2 by 3 C. Total charge is total capacity into total voltage, which is 2 by 3C, and voltage is 10. I'm not putting values at the end. I will. So voltage across first one is Q total upon C1. Q total we got 2 by 3, that is 20 by 3 C. Upon C. By 3 by C. This makes 60. 60. upon C cancel equals to 1. The charge is one second. I found voltage given charge. Charge on first and second both are same. Charge will be CS, that is 2 by 3 into C into voltage. 2 by 3C, that is equals to voltage 10 बराबर था. I made mistake. Diagram was not given. This is by judgment I gave the value. This is 10 volt. 10 volt. So 2 by 3 into 10. That is 2 by 3 into 6 into 10. 3 into 6 equals to 40 microfarad. So whenever you want charge in series, first find total capacity. Keep this fixed in mind. This also completed.
Yes, sir.
Capacitor A is charged to potential of 100 volt. Capacitor A, which is 5 microfarad, is charged to 100 volt. Another capacitor 10 microfarad is charged to 75 volt. They are connected by switch. So charge on first one is C1 V1. Charge on second one is C2 V2. That is 5 into 100 equals to 500. This is 10 into 75 equals to 70. When this switch is joined, then plus, minus, plus, minus, plus, minus, the connection will become like this. These are like terminals are connected together or unlike plates are connected together. How it is behaving?
Unlike.
Unlike plates are joined together. This is unlike plates joined together. So unlike plates are joined together, as we see from the diagram, they want what will be the charge on A and B after key is closed. So when this is situation, initial charge was Q1, Q2, what is charge after that? So whenever it is case of two individual are joined together, First, always find total charge. The total charge will become Q1 when unlike plates are joined together. Total charge will be Q1 minus Q2 when unlike are joined together. Like, then it will be sum. So 500 minus 750, that is equals to 250, equals to 250 in magnitude. So charge after they are joined together Q1 dash is given by C1 upon C1 plus C2 of total charge, which is equals to this formula. Please remember. How I got, once again I will explain you after you complete this sum. So C1 is 5, C1 plus C2 will become 15, total charge is 250, 5 into 3, so 250 upon 3 is charge on first one after they are joined together. Q2 dash, please copy this one because space is not there, then Q2 dash I will do. Q2 dash equals to C2 upon C1 plus C2 of total charge. C2 is 10, C1 plus C2 is 15 into 250, 5 into 2, 5 into 3, 500 upon 3.
Done, sir.
Now just see that note, how that charge gets divided. When two condensers are joined together, then they exchange charges till voltage of first becomes same as second. So voltage formula is Q1 dash upon C1. This is Q2 dash upon C2. So Q2 dash will be Q1 dash upon C1 into C. But total charge Before and after are same. So Q1 dash plus Q2 dash is total charge. That will become Q1 dash plus Q1 dash C2 upon C1. So Q1 dash common 1 plus C2 upon C1. That is Q1 dash C1 plus C2 upon C1. Q1 dash is C1 upon C1 plus C2 of total charge. Then Q2 dash will become C2 upon C1 plus C2 of total charge. So I wrote that one. Just write down for your understanding why we are writing Q1 dash Q2 dash formula as C1 upon C1 plus C2 and C2 upon C1 plus C2. Yes, notice done.
Yes, sir.
Yes, sir.
Similarly, when two spheres having charge Q1, Q2, radius R1, R2 are joined together, then new charge Q1 dash and Q2 dash we have to find. So again they will charge and exchange their charges till voltage is same. So for sphere voltage is 1 upon 4 pi epsilon naught Q1 upon R1, 1 upon 4 pi epsilon naught Q2 by R2. After charging, let charges be Q1 dash Q2 dash. So again same concept, Q2 dash is Q1 dash R2 by R1. So total charge is Q1 dash plus Q2 dash, which will be Q1 dash plus Q1 dash R2 upon R1. Therefore Q1 dash common 1 plus R2 by R1, which is Q1 dash is R1 plus R2 upon R1. So Q1 dash will be R1 upon R1 plus R2 of Q total, and Q2 dash will become R2 upon R1 plus R2 of Q total. These two formulas for condenser and sphere, please remember if they are connected together to get distribution of charge.
Done, sir.
Remaining 4 5 sums are almost using this concept. 103. Initially, sphere A has charge of minus 50 microcoulomb and B has charge of plus 80 microcoulomb. That means total charge at the group is minus 32 microcoulomb. The sphere A has radius 3 times that of B. If they touch each other, what is charge on sphere B? Charge on sphere B is RB upon RA plus RB into total charge. RB upon 3 RB plus RB total charge minus 32. That is RB upon 4 RB into minus 32. RB equals to minus 8 microcoulomb. So charge on B is minus 8 microcoulomb. Options. Okay, done.
Yes,
Yes,
sir.
sir.
104. In the figure, capacitor A and B has identical geometry. Identical geometry means their dimensions are same. Identical geometry. But a material of dielectric constant 3 is present between the plates of B. So if this is C and this is having dielectric constant K equal to 3, then its capacity will become 3 times, because C is equals to A K epsilon 0 by D. So if C1 is air, then it will be A epsilon 0 by D, and C2 is 3A epsilon 0 by D. That means C2 is triple of that first one. This is the meaning. The potential difference across them will be how much? So two capacitors are in series. I want potential across them. Charge will be same throughout. Hello? Charge will be.
Yes, sir.
If charge is same, total charge upon total capacity. First I am finding total capacity, then total charge, then voltage of first one is charge into capacity, दूसरे वाला voltage is V is Q by C. So whenever you see series, पहला series का capacity total निकालो. It is C into 3C upon C plus 3C square upon 4C D by 4C. Charge on first is same as charge on second is equal to total charge. It is total capacity to total voltage. That is 3 by 4C into 10. So it will become 30 upon 4C. Now, voltage across first is Q1 upon C1. Voltage across second is Q2 upon C2. First voltage is 30 by 4 C upon C equal to 7.5. Second one, 30 by 4 into C divided by 3C, that is 10 by 4 equals to 2.5, और total is 10, एक 7.5 हो गया तो ऑटोमेटिकली दूसरा वाला 2.5, so 7.5 and 2.5 required answer.
Done, sir.
105. A capacitor of 20 microfarad is charged to 500 volt, connected in parallel with another capacitor of capacity 10 microfarad, potential of 200 volt. Common potential V1. Common potential is C1 V1 plus C2 upon C1 plus C2. That means total charge upon total capacity. 20 into 500 plus 10 into 200. 20 plus 10. 500 into 20 will become 10,000 plus 2,000 is 12,000 upon 30. 3 into 4, 12, it is 400. Common potential formula is C1 V1 plus C2 V2, which is Q1 plus Q2 upon C1 plus C2. Nothing given means like plates are together. But if they say unlike plates are together, then difference of charge upon C1 plus C2, one sum we did that way also. Volt is common potential. Done.
Done, sir.
1 a conducting sphere of radius r, charge q, is connected to another conducting sphere of radius 2r and charge -2, then charge flowing through them. Charge flowing through them is clearly this is positive. ये charge इसको दे. So if I know initial charge on first one is q. If I find q1 dash, then q1 minus q1 dash will be the charge which is flowing. So let us see how to find q1 dash. q1 is q, q2 is minus 2q. So total charge will be q1 plus q2, that is q plus of minus 2q equals to minus. Now q1 dash is r1 upon r1 plus r2 of total charge. R upon r plus 2r of total charge. So this is r upon r of total charge minus q by 3 is the charge on first. So q1 minus charge flowing is the left out charge. q1 is original, minus charge flow is equal to charge left. So it is q minus q flowing is minus q by 3. Therefore q plus q by 3 is charge flowing. 4q by 3 is charge flowing. 4q by 3. Option D. Yes, done. 106.
Yes, sir.
107. Three plates ABC, each of area 50 centimeters square, have separation of 3 millimeter between both the plates AB as well as BC. Find the energy stored when the plates are fully charged. We want total energy stored in this system. We can see there are three plates ABC connected as shown. If I can identify the mode of combination series parallel, I can find total. If I get total, then energy will become half into total capacity into voltage square. So now my problem is how this arrangement is. Plate A is connected to positive, plate C is also connected to positive. That means A and C are joined together, these two plates, to the positive plate of battery. And B is joined with itself connected to negative terminal of battery. So this is which combination? Series or parallel? Yes, which combination? Series or parallel? This is which combination? Series or parallel?
Parallel, sir.
Parallel.
Parallel. So AB and BC both are parallel. Total capacity will become 2 times C, where C is A epsilon 0 by, now I am substituting for energy purpose, half into 2A epsilon 0 by D into voltage 12 square. To cancel, I am putting the values. A is 50 centimeter square means 10 raised to minus 4 meter. Epsilon naught 8.85 into 10 raised to minus 12. 12 square 144. And D is 3 millimeter. 3 into 10 raised to minus 3 meter. 3 into 4 is 12. Remainder 2. 3 into 8 is 70. 24. 3 4s are 12. Remainder 2 8s are 24. Is equals to now 48 into 50. 5 into 8, 40. 5 4s are 20. So 24. And this one 0 into 8.85 into 10 raised to minus 16 upon 10 raised to minus. So this is approximately 24 into 9 into 10 raised to minus 14 plus 9 into 4 36, 18 and 3 21 into 10 raised to minus 11. Now we'll check which format they have given answer in. Same or they have changed the decimal position. They have changed it. So this is 2.16 into 10 raised to minus 9 joule, which is closest to option 107 option. Yeah, done. 107 also.
Yes, sir.
Question number 10. A capacitor of 900 microfarad is charged to 100 volt. If its total energy is transferred to another capacitor of 100 microfarad, initially uncharged means 0 volt, then potential of second capacitor will be how much? V2 dash equal to 5. Because energy of first is transferred to second. So half of C1 V1 square is half of C2 square. Half of 900 into 100 square equals to 100 into 2 dash equal to 10. So this 100, I can cancel this one. So the square form. So taking square root, 900 square root will be 30 and 100 will be 10. V1 square I cancelled 100. So we get V2 equals to 300.
Done, sir.
A capacitor is charged by battery. The ratio of energy to the work done by energy stored by capacitor to the work done, energy drawn from the battery. So from the battery, work is charged into voltage, and between the condenser, energy is half of QV. There are three formulas: half QV, half Q square by C, and half CV square. Here I am using QV because work done can be written as QV. So ratio is 1/5. A fully charged capacitor has capacitance. It is discharged through small coil which is kept in insulated box. Mass is m, specific heat is given as. We want rise in temperature will be how. Energy dissipated by condenser is heat across coil. So half CV square is energy dissipated, heat is mass into specific heat into change in temperature. So half CV square. We are interested in what is voltage. square equals to 2ms delta T upon C. Therefore, B is root of 2ms delta T upon C. Option. This completes our 110 sums.
Done, sir.
Now the sheet which I have given you, please practice daily 20, 20, 20. Every lecture will discuss your doubt if you have any from next class onwards. The entire electrostatic completed for you all. Now just write homework for theory I am giving. Thursday, Friday, Saturday, Sunday, Monday. In this will complete entire theory. First question. State Gauss's law. Second, find E for sphere. Find E for long infinite wire, or we can say cylinder. Both. E for plane sheet. This is today's homework. With MCQ also 20. Friday. Potential due to point charge. Potential due to electric dipole. Saturday. Potential energy of system. Torque experienced by dipole. Potential energy of dipole. Potential surfaces. Relation between E and potential difference. Third, dielectric and polarization. Sunday, condenser and its principle. Condenser and its principle. Then CS CP formula. Last on Tuesday, capacity of parallel plate capacitor. Energy stored in condenser. Third, 20 gram generator. This completes entire theory of your electrostatic, which I have spread in around 6 days: Thursday, Friday, Saturday, Sunday, Monday, Tuesday. Tomorrow, I think all test on MCQ. Even I have taken photograph of this homework, and every lecture, whenever we meet, I will keep on asking. Now directly we'll meet on Tuesday. I will ask you attached status.
Done, sir.
New chapter, right heading: current, electricity. This is very small chapter, current, electricity. What is current defined as?
Rate of flow of charge.
Correct. Current is defined as rate of flow of charge. What is SI unit of current?
Ampere.
Ampere. What is Ohm's law? So long as physical state of conductor remains same, current flowing is directly proportional to potential.
Yes, sir.
Therefore, I proportional to V, that is V proportional to I, V equal to I here. R is called as resistance, which is also rho L by A. SI unit is ohms, correct?
Yes, sir.
Now in 12th standard, we are going to study relation between current flowing in the circuit and potential differences. So there was another scientist named Kirchhoff. He stated two laws called as Kirchhoff's law of electrical network. So first heading: state and explain Kirchhoff's law of Kirchhoff's law of electrical network. There are two laws we have to study. State and explain Kirchhoff's law of electrical network. First, Kirchhoff's current law. It is also called as junction law. It is also called as first law. So Kirchhoff's current law or Kirchhoff's junction law or first law, they are one and the same. Please write the heading.
Done, sir.
Kirchhoff's current law, junction law, first law. Current is a scalar quantity or vector quantity?
Scalar.
So how to add scalar? Algebraically or by geometric?
Algebraic.
Algebraic.
So first law states like this. Is stated. In an electrical network. In an electrical network. The algebraic sum of in an electrical network, the algebraic sum of electric currents. Scalar quantity, so we wrote algebraic sum of electric currents at any junction is always in an electrical network, the algebraic sum of electric currents at any junction is always zero. Junction means meeting point. So we have got many wires connected to this. Current will not stop, it will come and leave from some path because it is flow of charge. So if charge cannot be accumulated at any junction, current cannot be accumulated. It is flowing wala process. It cannot be stopped. It keeps on moving. So in an electrical network, algebraic sum of electric currents at any junction is always zero. Write this statement, then we'll see convention, then we'll draw diagram and understand how to apply that law. So
Yes.
at junction, total current is zero. What does it mean? All currents are plus plus plus. Yes, all current will be plus 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 then.
Yes, sir.
If all plus plus plus, how the answer will be zero here? Some plus, some minus, some plus, some minus, then only total can become zero. Na?
Yes, sir.
Like suppose we have current 3 plus current 2, दूसरा वाला current minus 5, तभी तो zero होएगा.
Yes, sir.
So which currents are now positive currents, which currents are negative current, that is our convention. The entering currents. That means that current which will come to the junction. Entering current. आया मतलब ज्यादा हुआ. So entering currents are taken as positive current. The entering currents are taken as positive currents. The leaving currents are taken as negative current. Right, two convention. Then next I will show you by diagram which one is positive and which is negative.
Done, sir.
Explanation. This is suppose one junction. Here I have got one resistance, 2, 3 and 4 resistance current. Suppose this is R1, this is R2, R3, R4 junction. I1, I3, I2, I4. So by Kirchhoff's current law at junction A, total will be 0. I1 is entering or leaving at A? I1
Entering.
Entering.
so it is positive. I2 is also entering, so that is also
Leave.
plus. I3, can you see it is leaving, so it is minus. I4 leaving, also minus, but total algebraic sum is. Followed this meaning?
Yes, sir.
Now actually it is based on Kirchhoff's current law is based on law of conservation of energy. Kirchhoff's current law is based on law of conservation of energy. Copy now.
Done, sir.
Kirchhoff's current law is algebraic sum of current at any junction is zero. Right? इसके ऊपर क्वेश्चन है. This is one diagram. I have to find what is I by using that Kirchhoff's current law. Try this. Very simple one. 3 is entering, 2 is entering. So this branch will have 5. Here, will it be 5?
Yes, sir.
Yes, sir.
5 में से 1.7 गया, ये कितना होगा? 5 minus 1.7 कितना आ जाएगा? 3.3.
Yes, sir.
Yes.
Current of EMF. 3 came, 2 came, add. निकल गया तो 5 गया, तो नेट इधर 0 ही हो गया. अभी बार-बार
Yes.
ऐड करने का जरूरत नहीं. Orally we can do this. Just copy this example of Kirchhoff's current law. Can I clear this now?
Yes, sir.
Yes, sir.
So first law we got Kirchhoff's current law. Second is Kirchhoff's voltage law. So two laws of Kirchhoff's electrical network. Kirchhoff's current law. Second is called Kirchhoff's voltage law, or it is called as loop law. Loop law or second law. So Kirchhoff's voltage law or loop law or second law. What is potential? It is scalar or vector? Potential is scalar or vector? Yes. Potential means energy. Scalar or vector? Scalar.
Scalar.
So its result is algebraic sum or geometric sum?
Also,
Yeah. So first statement remains same. In an electrical network. First line remains same. The algebraic sum of potential drops in an electrical network. The algebraic sum of potential drops across each resistances and EMFs मतलब बैटरी का वोल्टेज and EMFs enclosed in a closed circuit is always zero. So in an electrical network, algebraic sum of potential drop across each resistance and EMFs enclosed in a closed circuit is always zero. Copy statement, then sign convention, then diagram, then we'll apply Kirchhoff's voltage law. Two different loop to understand proper convention. Right.
Done, sir.
Everybody is done?
Yes, sir.
Yes, sir.
Now tell me, if this is resistance, current will flow from where to where? Yes, current will flow from where to where? Nobody is saying anything. Current will flow from where to where?
A to B.
No guarantee. Because I have not written which is higher voltage and which is lower voltage. If this is 10 volt and this is 2, then A to B is perfectly right. So current always flows from high potential to low potential. So this is 10, this is 2, मतलब इसने 8 खाया ना ये रेजिस्टेंस ने.
Yes, sir.
खाया मतलब अपना पॉकेट से गया ना 8. So when you are traveling in the direction of current, potential is dropped. मैं लिखूंगा minus convention. That means I will write minus IR because I have lost. But if I go from B to A, तो क्या हो रहा है देखो, 2 add 8 becomes 10, correct or not?
Yes, sir.
When we are in the direction of current, drop negative. उल्टा चल रहे हैं करंट ऐसा और हम लोग ऐसा जा रहे हैं, तो we are going on low to high side, will add. This is which terminal of the battery? Positive or negative? Again you can't say because दूसरा तो बना है नहीं. Now tell me कौन सा terminal है ये?
Positive.
Positive. And shorter one is negative. So when you are going from plus to minus, you are going from high to low, then EMF will be taken as negative. But if I travel ulta, low to high, then I will take positive. So based on this concept, in the direction of current, drop हो गया negative, ulta add हो गया positive, high to low negative, low to high positive. Keeping this in mind, we'll write now sign convention. 4 conventions will come. Sign convention. First, if we travel in the direction of current, then potential drop is taken as negative. If we travel opposite to current, then potential drop is taken as positive. Third, if we travel from negative terminal to positive terminal of battery, then EMF is taken as positive. 4. If we travel from positive to negative, then EMF is taken as negative. So high to low negative, low to high positive. Please copy this 4 convention. Once you complete, please tell, so that with diagram we will use convention.
Done, sir.
Okay. Yeah, can I clear it off?
Yes, sir.
I'm just drawing the diagram so that we can understand this sign convention properly. Set one battery of EMF E1, internal resistance R1. Another battery of EMF E2, internal resistance R2. Positive, negative. Two batteries are joined together to send current to the external resistance capital R. I can call this junction as A, this point as B, this as C, this is B, B, F, G, H. Current from E1 is I1, current from E2 is I2. At this point, they will add, becomes I1 plus I2, pass through resistance. When it comes at D, I1 will enter in its path and I2 will enter in its path. So this is current flowing distribution I have shown in the diagram. How many loops you all can see? How many loops you can see? 1 or 2 or 3, close to 5. Yes, how many loops you all can see?
2.
2. Open your third eye and check. I can see 3. एक ये पूरा ऊपर वाला, फिर ये नीचे वाला, फिर ये भी है ना ऐसा. So total how many closed
Sir.
loops you can see?
There is 2 opposite charges. How the third one is not possible.
Yeah. See, don't say it is not possible. You have to say
And it will be possible, but very low current will go.
we are not interested in current flow. We are interested in loop. So you can't say it is not possible. You have to check, is it possible? That will be correct. When you are saying it is not possible, means you are guaranteed. So let us check whether it is possible or not possible. I can see one loop is A, B, C, D, E, F, A. You can also see same. I started from A, reached to A. So one loop. Yes or no?
Yes, sir.
Yes, sir.
Second loop. A, B, C, D, H, G, A. I think this also you followed. There can be one loop, this one.
Yes.
Third one. A, G, H, D, E, F, A. Can I have this? A, G, H, D, E, F, A. This is also one loop.
Yes.
Yes.
If that means possibility is there, we can have three loops. Now applying Kirchhoff's voltage law to loop A, B, C, D, E, F, A, we get A to B. Is there any resistance A to B?
No.
Oh.
No. So there won't be any potential drop, because potential drop by Ohm's law is I into R. B to C, any drop?
Yes.
Yes.
Current is I1 plus I2 and resistance is R, so there is drop. We are in the direction of current or we are moving opposite? We are in the direction or opposite? Our direction is
In
in the direction, so negative. C to D, any drop?
no.
D to E? E2F, yes,
Yes.
I1 R1, but negative because R direction and current is same to same. Minus to plus means we are going low to high. So it is plus EMF E1 equal to this. So for first loop, I got Kirchhoff's voltage law applied. Not difficult, ये तो application and I have to understand. If I have understood, I can proceed. Tell me this one. Now, second loop. Applying Kirchhoff's voltage law to loop ABCDEF. Again, A to B, any drop?
No.
B to C same, I1 plus I2 into R, but negative. C to D, no drop. D to H, no drop. H to G, I2, R2 in the direction minus. Then negative terminal to positive, low to high, plus EMF equal to this. Everybody has followed at least this two.
Yes, sir.
Now third one, see, applying Kirchhoff's voltage law to loop A, G, H, D, E, F, A, we get. First I am applying to circuit, then battery I will see later. A to G, no drop. G to H, what is drop across resistance? Is it I to R2?
Yes, sir.
Plus or
Yes.
minus? I to R2, but plus or minus?
Plus.
Plus.
They are opposite to the current. E to E, nothing. E to F, minus I1, R1 because we are in the direction of current. Okay?
Yes, sir.
Fine. Now, checking the batteries. A to G any battery? No. G to H any battery? Yes, E2. Plus to minus is minus. Minus to plus when I go GH, HD, DE, EF. Minus to plus. Plus E1 equal to this. Clear now?
Yes, sir.
Draw the diagram. Write 3 Kirchhoff's voltage law. Note, we will write Kirchhoff's voltage law is based on law of conservation of energy. So with this we have completed Kirchhoff's current law, Kirchhoff's voltage law.
Done, sir.
Everybody is done?
Yes, sir.
So please revise and be alert on Tuesday. Tomorrow's test is on MCQ based. At least 25 or 50 numerical I will give from the sheet which we have discussed 1 to 100 and I think 8 or 10. So please keep on practicing as per the schedule which I have given for theory and 20 at least